Thank you for joining us to hear about our cloud-native journey at Intel. During this journey, we wanted to transform monolith legacy applications into cloud-native ones and also make a cultural change in our organization. This transformation talk is going to be a little bit different, maybe from other transformation talks that you heard before, because this one started from bottom to top. It didn't start from any director or CIO that decided, okay, we're going to adopt Pivotal Cloud Foundry or something like this. 3 months, puff, the organization is completely different. This story is a little bit different. It started by the developers who wanted to make a change. This platform that we created, we wanted to allow other software development teams to focus on business value creation rather than operational efforts. So I'm Roi. I'm working 11 years at Intel, and I have 4 years experience with different Spring projects. My platform team, which is based in Israel, by the way, developed a framework based on Spring Cloud and a PaaS solution to other software teams in our organization.
I'm Liel. I'm working 4 years at Intel and 2 years with Spring Boot and Spring Cloud, and I'm also a part of the platform team. So we're a part of a global group with 70+ developers that develop data center management solutions. Those solutions are operating the largest HPC environment in the semiconductor industry. Those solutions play a crucial role in the design automation workflows, drive all Intel chips validation activities, and is also used by Intel supercomputer. So any downtime of those solutions means a direct impact on Intel products' time to market. Our main solution, which is developed over the last 20 years, is a distributed batch job scheduler. It runs millions of jobs per day on 59 different data centers. Those jobs are usually a part of a more complex flow that has dependency between different groups of jobs. They may run on a remote data center and have a large data set, so we need to replicate the data between the data centers. And also, managing 59 data centers with 227,000 servers is challenging. The servers need to be patched regularly with minimal effect on the utilization of the data center. To solve those complex changes, the group consists of several teams, beside our platform team, that develop batch, interactive storage, and automation solutions. We use Java as our main programming language and JavaScript for front-end.
Okay, so let's talk about where we were when we started our cloud-native journey. We identified problems in 3 main areas: technical, process, and people. So all our solutions were not services, but products. They were all huge monoliths, and by huge, I mean more than 1 million lines of code, each one of them, running on stateful servers using in-house Java framework that was introduced when Java was in version 1.1. I don't know if you all know, but 1.1 even didn't have thread pools, for example. It's that old. This meant a single point of failure, and scaling those solutions was very expensive for us. The onboarding time for a new developer was around 6 months till becoming somehow productive, not productive, somehow. Every change we made to the code base meant taking a huge risk. We found ourselves many times avoiding complex changes, even when the business demanded. We said, okay, no way. It was not uncommon for the first feature of a new developer to cause negative impact on customers. In production, it can be either a major incident in the environment or just an incident. We had a separate development and operation teams. The development team was providing an artifact to the operation team, and they in turn were in charge of globally deploying it to 59 different data centers. Globally deploying a new version could take around 4 months, which led to low usage as our features were always late to market. Since we didn't use any open source projects at all, we started to lose our best developers to more modern software companies. We also found it hard to recruit great new developers considering the competition in the software industry today. Today, developers would like to work in a place that will also contribute to their career. In addition, our developers were spending around 50% of their time doing support. This led to very low motivation, and they started to seek for new challenges. We had huge unmeasured technical debt, and to the lack of unit tests, the developers are hardly investing in ongoing refactoring to reduce it. This huge number of complex tests led to a long developer feedback loop due to 7 hours regression. Those complex tests that I talk about, we had almost 0 unit tests in our code, and more than 10,000 complex end-to-end tests that required each one of them several servers. Those tests were written by a different QA team in a different geographical location. So like I said, this led to a very long developer feedback loop due to 7 hours regressions. And those regressions were never really stable. Every time we had an inconsistent test or environment issues, so the regression was never green. We were working in a 6 weeks waterfall sprint. And for the last week of the sprint, every time we found ourselves trying to stabilize the master. Another issue when having a different QA team is that your developers are lacking the end-to-end responsibility on the code they write. They have someone else testing it and someone else deploying it. So all of those problems prevented us from taking our business forward and meeting the business needs.
So before we move on, we want to let you understand what is the culture, what the culture was in our organization. The organization culture was to limit changes, where every change in the environment required us to go through change control committees and war rooms approvals. And when I say change control committees, I mean many of them. Pushing a new version to production required us 59 different change control committees. Each of those changes was relatively big, so it translated almost every time to negative impact on the environment and to low customer trust. It resulted in several long freezes during the year. Even within the development teams, the mindset was, if it is working, don't touch it. Or when speaking of technology and architecture, it worked until today. Why do it differently? This situation caused us to tackle it step by step without introducing any radical changes. We leveraged an existing mature deployment solution we had instead of taking a full-blown working solution such as Pivotal Cloud Foundry. We also have some technical constraints. Our customers require low latency response from within Intel data center. And the huge data sets that we have just can't go over the network. So we can't run on public clouds. Also, Intel huge data centers are there, so we can leverage them. Hopefully, now that you understood what our situation was, we will try to move on and explain how we handled it.
Okay, so we came to the conclusion that if we want to be able to move fast and address our business needs, we must leverage open source projects such as Spring and not reinvent the wheel all over again as we did until today. We started by integrating Spring Boot and Spring Cloud to all our solutions by developing an in-house framework based on them. As you all know, Spring works great with almost everything. So we provided a framework that integrates easily with all our stack so developers can concentrate only on the problems they need to solve. We wanted to have an easy and unified way to generate, build, and deploy services. So we created a service generator and developed a Gradle build plugin to enforce all our build constraints, such as minimal code coverage, static analysis, the way to push artifacts, and etc. We established an end-to-end responsibility for all our developers. And by this, I mean you write the code, You deploy it, you test it, you monitor it. No one else will do it for you. Or in other words, you build it, you run it. We set a goal to increase our test coverage, increase our confidence in new changes, and reduce the developer feedback time. To achieve that, we educated the team to write more unit tests and added several other testing layers, such as integration tests and contract tests. Now we are able to conduct ongoing refactoring on existing code and reduce our technical debt continuously. To measure and control our technical debt, we added a static analysis tool to our workflows. So every pull request gets immediate inspection and the developer gets feedback on the pull request itself. When you want to prove that moving fast is possible but also beneficial, it's crucial to prevent bad deployments and control the customer impact. We use Spring Cloud pipelines and Concurse CI to implement automatic CD process that push gradual changes to production after every commit. By gradually, I mean that we don't push to production directly. We go to test and integration environment first. And even within those environments, we have the ability to target specific users or groups. We integrated the monitoring and telemetry information into our deployment pipeline. So we automatically inspect and roll back bad deployments. For example, we compare the server error rate of a new instance to all other instances, and if we exceed a certain threshold, we automatically roll back to the previous version. As part of our end-to-end responsibility efforts, we introduced a PaaS solution to all our developers, allowing them to control several aspects of their services, such as configuration, security, alerts, and runtime. Till now, we only heard about production issues when a customer contacted us. We realized that we must make a change to a more proactive approach. So, in addition, as you all know, observability is a key concept in cloud-native application. As the complexity grows and there are many more failing points. So we enabled dashboard and alerts based on all our telemetry information and logs, integrated health checks, and provided a log aggregation solution. Utilizing our framework and Spring, we were able to create a common layer of alerts for all common issues in all applications. So when a developer develops a new feature, he only needs to focus on his own feature. Everything else is already being taken off.
So we will drill down to the deployment activity and talk about the API gateway, which is a key component in our platform. In cloud-native applications, services are going up and down constantly, and clients should not be aware of their location or existence. There are many more failing points, as requests are going over the network and not as inter-process communication. And security becomes an issue, as we no longer have a single component to secure. The API gateway, which is based on Netflix Zul, is the entry point for all clients to services running on our platform. It helps us abstract the internal architecture of our solutions from the clients. And only edge services, which are services that register themselves as edge in the service registry, are exposed by the gateway. The gateway enables us to solve common challenges in a single place. It handles the authentication, the encryption. It handles rate limiting, retries, load balancing, and much more, instead of our developers. We also believe that going cloud native without a continuous delivery is not a real win. To do so, the API gateway controls the traffic to services based on different criteria, such as weight. So we can dynamically increase the exposure of new versions. It supports different application topologies, such as zone affinity applications that can fail over between the data centers, and zone exclusive applications. And we also have the ability to create an isolated sub-environments. The isolated sub-environments enable us to route traffic to it based on the user, the group, or the URL. So we can leverage this capability in order to target a specific user to a specific instance in production and debug it online without affecting any other user. This way, we can avoid all the negative impact on important customers and significantly reduce the debug time. As Roi mentioned, we've implemented the continuous delivery pipeline to all our solutions. At the beginning, when we've implemented this continuous delivery pipeline, our developers were required to observe all the dashboards and manually decide if the newly deployed version behaves as expected. We felt that our automatic continuous delivery pipeline is not that automatic because we are relying on this manual inspection of the developer. So we have developed a smart automated tool that compares the newly deployed version against the existing ones based on telemetry data, based on the alerts and the health information of the services. This tool monitors some predefined metrics, such as the server errors, the client errors, the memory consumption of the services that are running, the new one and the existing ones, the REST API performance, and other service-specific metrics. Those specific metrics are defined by the developer. During development, it is a part of the code review, and it's also a part of the code base. The tool will roll back the deployment if a certain threshold of any metrics is reached. Since we integrated this into our continuous delivery pipeline, our developers feel free to deploy new versions to production without any need to observe the dashboard as they did before. This tool enforces our preconditions into the continuous delivery pipeline. This way, it significantly reduces the impact on our production environment.
So it's a nice story. So what did we get from all of this? By going to the DevOps route and changing our testing methodologies, we were able to have a green and stable master all the time, which allowed us to release a service after every commit. We moved from a product approach to a service approach, which allowed us to deploy on a weekly basis based on the business needs. We became much more agile. We shortened the feedback loop from our customers, which led to more useful features for them, and they really started to use them. The different deployment methodologies, monitoring, end-to-end approach, and the automatic fast rollback that Liel talked about reduced the amount of production bugs significantly and the impact on customers. Before, we only heard about production issues from customers. Today, we are able to identify those problems even before the customers even identify or notify them, roll back or fix with no impact at all or with minimal impact. This led to higher confidence from our customers and helped us to convince the organization that frequent small changes is the right direction. So basically, we were able to prove them that it's possible to move fast without breaking things. That's it. If you have any questions, we're happy to answer. Yes. Yes.
What percent of the team at Intel is working in the way you described? Are you a small group, or is this permeated across the entire IT operation?
So I would just return on the question. So if this transformation is related to whole IT, so no, as Intel IT is a huge organization, we are part of 70 developers, as Liel said. Within Intel IT, it's called the HPC department, which we are like in charge of the data center management. So this transformation relates to us. As I said, it didn't come from the CIO or something like this. We felt that we are doing it wrong. And we as the developers went and started to change things because we couldn't really convince the management otherwise. So we did it step by step, and today we are in a different place. Thank you.
Okay. Any other questions? Yes.
Yes.
How did we get the business owner to prioritize working
Again?
How did you get the business owner to prioritize working on that?
The question is, how did we get the business owner to accept this change or let us have the time to work on it, on this transition?
It was a long journey. At the beginning, we got a lot of no's. No from everybody. So we set up a very small group and started to work on it on the background because everybody told us it will not work, it's not possible, the culture in the organization, there is change control. So we said, okay, let's take a very small group and try to do different things in a very certain, not that critical business project that we had. And then after we improved that we are able to do this, we said, okay, let's try to take another portion of the business and prove that we can do this also there. So it took us step by step, but we need to start it without any formal approval. This is the way that we were able to achieve this.
Yeah, it was long.
Yeah, it's not a 3 months transition. We are doing this for 2 years. And like I said, there were huge monoliths. Many of them very big. Transitioning them to a cloud-native application can be very long process from technical perspective also, not only the cultural change that we had to go through. So we just started with something small, proved that we can do it, and then when you bring results, the business can really, you show them that you can do this that fast, they will join you. Sometimes it's hard to convince them that it's possible because they believe that, like I said, freezes, no changes, nothing. Let's let the things work. Even if sometimes we had bug fixes and things for customers, but no, don't touch it, even if you have this fix.
We prefer the bugs we know about and not the bug we don't know about and
Yeah.
you want to deploy to the new environment. We can't, okay, so the question is if we are now running on a public cloud or we're still running on-prem. So the answer is we are still running on-prem. As I described the technical constraints that we have, we still have them. We can't run outside of Intel data centers. It's just the latency is not good enough for us to go out.
Yes, if we could run on public cloud, it probably could make our life easier. But we cannot, also from security, IT, all the stuff, the secret stuff that Intel is running on our solution, so it's not very feasible for us to run on public cloud. And like Liel said, we had huge data centers already there, so we leverage them. Yes, sorry.
So what I heard was you are transforming an existing application, right, in your capabilities like this. So you also mentioned technical debt. So I'm just curious, how do you balance paying off technical debt versus new features, and how do you prioritize that?
Great question. I will repeat it. How do we prioritize the technical debt of the existing solutions and do the new ones? So we use SonarQube as a static analysis tool. And it is a very great feature to allow us something called time window. So it allows you to measure the technical debt that you create on the new code, because when we measured our monolith, it was impossible to really reduce it or control it anymore. But what we wanted to make sure that new code that goes into the monolith will not increase the technical debt, and this allowed us. And to make sure that new projects, those new services that we started to extract out, don't have this problem as the monolith before. So it became part of the culture of the developers and the technical leaders to see that now we are going to work a little bit differently. Also, developers in the beginning didn't like it because someone else, which is not human, start to give them some feedback. So you need to stick to it, and at the end they realize that they really helps them and prevent them from waking up at the middle of the night when there is an issue because something that you didn't check.
On the technical perspective of it, the developers are writing the new code, are handling the new features, but always they are touching a part of existing codes. So they refactor. They refactor the existing code to reduce the technical debt. They're not handling the technical debt without the need to touch the
we
code.
didn't say, okay, now we're going to reduce this technical debt for 3 weeks. Yeah, we didn't go there. Yes.
He wanted to.
Sorry. I
Okay, so you talked about this huge change control process that we had. So, like I said, we started like a very small project, and we showed them that you don't need to go through that many change control committees, because if you want a continuous delivery and deliver a few times a day, or one time a week even, you cannot go to 59 different change control committees, right?
But do you have any form of change process before the developer deploy?
So
it is coded inside our continuous delivery pipeline. Our continuous delivery pipeline, as we said, runs all the tests. You can't reach to production without running all the tests on your code. And also the monitor tool, after the deployment, monitors the environment. So if anything is not working as expected, it just automatically roll back and tells the developer, this deployment failed. Now take the logs, take all the telemetry data, try to understand what went wrong, and deploy again at the new version with the fixes.
Yes, I attended many of those change control committees, and I just saw they have the same questions every time. Did you test it? Did you deploy it to the integration environment? Did you test with some kind of test group? So what we did, we just coded this into our environment using the concourse and API gateway to target specific users. We have more critical customers to our solution and less critical customer solution. So we first deploy to them, see that everything is fine, and go on. So we just codified it into our process.
We had a question over there.
Yeah. So the second, you migrated a monolith application to a microservices, right? It may have taken multi-months to do that.
Yeah.
So how did you manage, like, did you making it changes to the monolith and microservice family? Did you get to some stage to go with the new approach, or can you explain?
So you asked about how we did this separation of this huge monolith into microservices. So when we started, we were thinking that it might be possible to go to the greenfield and just write it from scratch, and then we woke up and we understood that it's not possible. So we did two things, basically. First, we take a decision that new code will not, by default, go into the monolith. We will first try to make it outside. This was the first rule, to not make it even bigger. And then we identified one issue that is not critical, but also important in our monolith, and tried to extract it. This is how we started. And when we started and we showed that it's possible, so we learned a lot first by doing this. We made many mistakes from architecture, design, everything, but we learned. And then we move on and moved on. So every time we just tear another part of the monolith, put it outside, and every new code, if 3 years ago, if someone came with us with a business need, we were sure, said, okay, this goes into the monolith. Today is first, let's see if it fits to any other of the microservices, or maybe it's a different new microservice, but we don't put more into the monolith. So this also allowed us to reduce the production bugs, because like I said, every change in this huge monolith, you can go clean with this. You either break thousands of tests or make a production issue. Yes?
Did you address breaking up the monolith database to put the data source for each microservice, or you just leave it monolith database?
So I will repeat the question, did we address to break the database, or did we keep it a monolith database? So basically, our monolith didn't use any database.
It used
like
in-memory and file-based
persistency on the disk. This is one of our biggest problems. So we didn't have these architectural problems, but what we did is one of our first architecture rules was to not have a monolith database, because when you go to microservices, this probably will kill you when you start to have dependencies between services, but the database is share them. So we did go to a database per service pattern, and all the complexity, like I said, of Cloud-Native, that you need a distributed transaction through Kafka or stuff like this, sagas, patterns, and etc. So I think we're out of time. So we are out. If you have more questions, please rate our talk if you have time in the mobile app, and we are out there if you have any questions. Thank you very much.
Thank you.